4 billion years ago, Earth was a barren wasteland. Lava flows, toxic skies, a planet screaming with chaos. And then something arrived. Something not from here. A tiny hitchhiker, clinging to the icy surface of a comet or buried in the rock of a meteorite. Microscopic, unassuming, but carrying the spark of life. This wasn't an accident. This wasn't random. These microbes, alien in every sense, landed on Earth and began to thrive, feeding off its mineral-rich chaos, evolving into the vast web of life we see today. Here's the shocking truth. Life as we know it didn't originate here. It was seeded from the stars. And if that's true, then everything changes. Earth isn't our home. It's just the first stop on a much larger journey. Because we're not Earthlings. We're the aliens. And we were never supposed to stay. To fully appreciate the potential of directed panspermia, the idea that life on Earth has extraterrestrial origins, we need to take a step back. Before we dive deeper into this captivating possibility, we owe it to ourselves and to the pursuit of truth to explore the other explanations science offers for how life might have begun. Now, I'm not talking about wild guesses scribbled on the back of a cocktail napkin. These are legit, big deal theories built on decades of people in lab coats, running experiments, arguing, and occasionally yelling, "Eureka!" But here's the thing. Science is like a jigsaw puzzle you picked up at a yard sale. Some pieces are missing, others don't quite fit, and you're left squinting at the picture on the box trying to figure out what you're looking at. The theories we're about to unpack, they've got some solid points, sure, but they also leave us with a lot of head scratchers. So grab a drink, settle in, and let's walk through these ideas. We'll see what they explain, what they don't, and why they're not quite the slam dunks some think they were. Real quick, before we go any further, this channel doesn't run on ad dollars or brand deals. It runs on you. If you want to help keep the lights on and the rabbit holes open, please hit subscribe. It's free, and yeah, it makes a huge difference for the channel. All right, let's keep going. Alright, so let's talk about one of the most popular theories for how life got started on Earth, abiogenesis. Big word, I know, but it just means life popped up all on its own. No alien interference, no cosmic seeding program, just Earth doing its thing. According to this idea, life didn't need any outside help. Nope, it was all about chemistry. Picture this. Billions of years ago, Earth was a hot mess. Shallow, mineral-packed oceans, think of them as nature's primordial soup, were stewing away. Now toss in some basic ingredients: methane, a gas that smells like bad eggs, ammonia, the stuff in window cleaner, hydrogen, and water. These molecules collided, mixed, and eventually teamed up to make amino acids and nucleotides, which are basically like the Lego bricks of life. But the kicker? Energy was everywhere. Lightning strikes lit up the sky. Volcanoes were erupting like party poppers. Ultraviolet UV rays from the sun were sizzling everything. And hydrothermal vents, basically underwater geysers, were adding heat and chemicals to the mix. It was chaos, but the kind of chaos that's perfect for cooking up something extraordinary. In 1953, two scientists, Miller and Urey, thought, hey, what if we could recreate that primordial soup in the lab? So, they set up a contraption that mimicked early Earth, a glass chamber filled with gases, and zapped it with electricity to simulate lightning. Boom! Amino acids formed. It was like nature's cookbook handed over its first recipe, the building blocks of life. Pretty cool, right? But here's the real head scratcher. How did those tiny molecules take the next step and organize themselves into something as complex as a living cell. The theory points to RNA, ribonucleic acid, basically DNA's chill cousin. Unlike DNA, RNA can store information and catalyze, speed up, chemical reactions, which makes it the MVP for early life. So maybe RNA got the ball rolling by replicating itself and passing along some early genetic codes. Then comes the next leap, cellular structures. The theory says lipid molecules, or fats, might have naturally formed these tiny bubbles, or vesicles, in the soup. These bubbles acted like little containers, protecting the fragile RNA and other molecules from the harsh environment. So, congrats, Earth! You've got protocells, the world's first attempt at life. Imagine Earth as a cosmic kitchen. Lightning and volcanoes are the chefs, stirring up the steamy chemical stew until, voila, amino acids and molecules just show up. Then these molecules are like, hey, let's form a club. And eventually they get their act together and become the first living things. The Miller-Urey experiment showed that organic molecules can form under the right conditions. But yeah, let's not ignore the elephant in the room. Jumping from a couple of amino acids to something that can self-replicate, metabolize, and evolve? Well, that's one massive leap. Maybe it happened, just like the textbooks say. Or maybe there's a missing ingredient here. Something we haven't figured out yet. Abiogenesis gives us the classic story of life starting on the surface. But some scientists think the real action was happening way below, like miles below, at these things called hydrothermal vents on the ocean floor. If you've never heard of hydrothermal vent, imagine a giant underwater volcano spewing super hot water loaded with all kinds of minerals and gases like hydrogen sulfide, smells like rotten eggs, but hey, microbes love it, and methane, yep, the same stuff that makes cow burps infamous for climate change. It's basically a bubbling chemical cocktail happening in an environment so extreme it makes you wonder how anything could survive there. Here's the theory. These vents, which scientists sometimes call black smokers because they look like chimneys puffing out dark plumes, could have been the perfect hangout for life to kick off. All that hot, mineral-rich water could have acted like a natural chemistry set, with the minerals around the vents playing the role of matchmaker for molecules. The result? Biochemical reactions that might have been the first steps toward life. And believe it or not, we've got modern-day proof that life loves these crazy spots. There are microorganisms called extremophiles, basically tiny life forms with the attitude of a rock star. These guys thrive in boiling heat, crushing pressure, and toxic environments that would kill most living things. So it makes you think, well, if they can do it, why not the first life forms? Imagine this. Deep in the ocean, these hydrothermal vents, basically nature's underwater geysers, are blasting out superheated mineral-rich water. It's like a buffet of chemicals and energy, which might have been just the thing tiny microbes needed to thrive. These little guys could have fed on all the good stuff coming out of the vents and gotten their start in life's toughest boot camp. It sounds nuts, but then you realize how many extremophiles, those crazy tough microbes, live near these vents today. And it kind of makes sense. These little guys are basically like, oh, you thought this was hard? This is where we thrive. So yeah, it's extreme, but maybe life isn't as fragile as we think. Still, I can't blame you for finding it a little hard to swallow. Maybe we're missing a piece of the puzzle. Heck, maybe the puzzle's even bigger than we realize. There are some other ideas in the mix too, kind of like the runners-up in a science fair. They're variations of the main theories we've already covered, each trying to explain how life might have gotten its start. For example, the deep-sea alkaline hydrothermal vent theory is like the black smoker hypotheses' chill sibling. Instead of chaotic acidic conditions, It imagines a more relaxed, pH balanced environment where early life could have emerged. Think of it as the spa version of the underwater volcano idea. Then there's the RNA world hypotheses, which puts RNA in the spotlight as the molecule that started it all. RNA, by the way, is like DNA's scrappy older sibling. It's a molecule that can store genetic info and do chemical work, which makes it a prime suspect for the whole first life situation. Basically, RNA could have been the original multitasker before DNA and proteins showed up and specialized. Next, we've got the iron-sulfur world hypotheses. This one argues that life might have started on shiny metallic minerals like pyrite, aka fool's gold. The idea is that chemical reactions on these surfaces could have jump-started life, with iron and sulfur compounds playing the role of matchmakers. And finally, there's the clay hypothesis. Yep, clay, good old mud. This theory says that mineral surfaces in clay might have acted like a mold, helping organic molecules line up and connect in ways that eventually led to life. It's basically like Plato's school of thought. Nature used whatever was lying around to shape the building blocks of life. Science is basically a giant game of what if. Sometimes it's brilliant, and other times it's just throwing theories at the universe and hoping one lands. But yeah, when you step back and look at these ideas all at once, it does feel like nature was working through every option in its cosmic cookbook. And instead of giving us clear answers, it left us with even more questions. Classic science move. These mainstream theories are pretty incredible, no question about it. They're the result of generations of scientists rolling up their sleeves and trying to crack one of humanity's oldest mysteries: where we came from. Each theory gives us some juicy clues, but they also leave us with some big gaping question marks. For every riddle they solve, it feels like two more pop up, like some cosmic game of whack-a-mole. And here's the kicker: none of these theories really nail how life made the leap from a bunch of random chemicals to actual living, breathing, reproducing cells. They're great at listing the ingredients, but when it comes to explaining the recipe, how you mix, bake, and end up with the miracle of life, we're left scratching our heads. It's like someone handed us a box of cake mix, but forgot to include the instructions or the oven. This is where things start to get a little more interesting and maybe a bit weird. Because if the idea of panspermia has even a hint of truth to it, then the missing recipe might not be from Earth at all. Let's take a moment to size up the mainstream theories about how life got its start. We've got abiogenesis, hydrothermal vents, the RNA world hypothesis. They're like pieces of a puzzle. The problem? It feels like half the pieces are missing, and someone lost the picture on the box. Even after centuries of research, these theories leave us with way more questions than answers. Take abiogenesis, for example. It's the idea that life somehow arose spontaneously from a chemical soup. You've got this primordial mix of water, methane, ammonia, hydrogen, all the ingredients you find in nature's janky kitchen. But even with cool experiments like the Urey one, where scientists zapped a pretend early Earth soup with electricity and got amino acids, the building blocks of life, we're still stuck in the big question: how do you go from simple molecules to a fully functional self-replicating system? It's like looking at a pile of Legos and expecting them to assemble themselves into the Millennium Falcon just because you waved a lightning bolt over them. Where's the definitive proof? Then there's the hydrothermal vent hypothesis. This one argues that life started not on the surface but deep down in the ocean at hydrothermal vents. Basically underwater volcanoes that spew super hot mineral-rich water. These vents have all the right raw materials, and some modern extremophiles, microbes that love living in places that would kill most things, thrive in similar spots today. But here's the problem: no one's been able to recreate the whole process in the lab. It's like having all the ingredients for a cake, but realizing you've got no oven and your kitchen's underwater. And let's not forget the RNA world hypothesis. RNA is a superstar molecule. It can store genetic info like DNA and even catalyze chemical reactions like proteins. But here's the catch: RNA is fragile, like really fragile. In a chaotic prebiotic world where meteors were crashing and volcanoes were erupting, how did something so delicate stick around long enough to kickstart life? It's like trying to keep a house of cards standing in a hurricane. Mainstream theories, while fascinating, still hit us with some major head scratchers. Where did the first self replicating molecules come from? Did they just materialize out of nowhere, or is there a missing piece of this story we haven't found yet? What about the Cambrian explosion, when life on Earth suddenly got super weird and diverse, like nature hit the evolution on steroids button? Why does it look more like a cosmic switch got flipped than a gradual process? And why, for the love of science, haven't we been able to recreate the genesis of life in the lab yet? We've got all this technology and knowledge, but no one's cracked the code. Don't get me wrong, these theories are groundbreaking and have taught us a lot about life's building blocks, but they feel incomplete, like trying to assemble IKEA furniture with no instructions, and maybe a few missing screws. And those unanswered questions, they're not just gaps, they're massive gaping holes you could drive a spaceship through. Let's talk about the Cambrian explosion. It's one of those moments in Earth's history that makes you stop and go, wait, what? About 540 million years ago, life on Earth went through a glow up that was nothing short of insane. Before this, it was all pretty simple: single celled organisms, clusters of microbes, and a few multicellular critters just floating around, taking their sweet time evolving. And then, bam! Out of nowhere, the planet suddenly gets a VIP pass to evolution's greatest hits. In what's basically the blink of a geological eye, complex organisms crash the party. We're talking eyes, limbs, nervous systems, shells, the whole package. It's like nature was running on dial up for billions of years and suddenly upgraded to high speed fiber. Evolution's slow crawl turned into a full on sprint. It's not just impressive, it's downright suspicious. Take trilobites, for example. These guys had segmented bodies and compound eyes that look like something out of an alien invasion flick. And then there's hallucigenia, a creature so bizarre it looks like it wandered out of a Tim Burton fever dream with spikes on its back and tentacle legs. These weren't gradual steps forward, it's like they showed up fully assembled. Fossils reveal this explosion of diversity, but they don't explain how or why it happened so fast. Now, mainstream science has thrown out a few theories, but none of them feel like a slam dunk. One idea is that rising oxygen levels created the perfect environment for life to thrive. Oxygen's definitely important. Try living without it. But it doesn't explain how genetic blueprints for eyes, exoskeletons, or entirely new body plans just poofed into existence. Another theory blames it on mutations or DNA duplications, basically nature's way of shaking things up. But why would those changes suddenly happen so fast and on such a massive scale? Evolution is supposed to take its time, but the Cambrian explosion makes it look like it was in a hurry to meet a deadline. Then there's the predator-prey arms race theory. This one argues that as predators showed up, prey species had to step up their game, evolving shells, defenses, and new survival tactics. But again, this doesn't explain the sudden arrival of entirely new body plans that no one had seen before. It's like nature went from sticks and stones to 3D printed titanium in a heartbeat. The Cambrian explosion isn't just a head scratcher for paleontologists, it's a full on migraine. It's a big glaring wait, what? In the story of life on Earth. It's supposed to follow a slow and steady evolutionary path, but this event flipped that script. Mainstream science recognizes the explosion happened, but no one's nailed down a theory that actually fits. Where did life really come from? Here's a thought. What if the gaps in those theories aren't just dead ends, but neon signs pointing to something bigger? Something, dare I say, cosmic. Enter panspermia, the idea that life didn't start on Earth at all. It hitched a ride from somewhere out there in the great beyond. Stick with me here. Imagine tiny microbes clinging to comets like interstellar hitchhikers, surviving the brutal vacuum of space, or better yet, being sent on purpose by some ancient alien civilization. Yeah, like Galactic DoorDash, but for DNA. It sounds like sci-fi, but it's actually grounded in science. And the more we dig, the more evidence we find that this wild idea might just hold water. The big question is this: are we paying attention? And here's the kicker. This isn't just a story about panspermia. It's the story of us. Panspermia. Yep, it's a mouthful, but stick with me. It's the idea that life didn't start here on Earth. Nope, it got here from out there. Picture this: tiny microbes hitching rides on comets, asteroids, or even interstellar dust, cruising through the cosmos like intergalactic backpackers, and eventually crash landing here on Earth. It's a theory that flips the script, suggesting Earth isn't the birthplace of life, but just one pit stop in an epic cosmic road trip. There are a few ways this could have gone down. First, we've got lithopanspermia. This is the idea that microbes hitched a ride on rocks blasted off a planet after an asteroid impact. These hardy little travelers somehow survived the cosmic journey and decided Earth looked like a nice place to set up shop. Then there's radiopanspermia, where microorganisms or spores get propelled through space by radiation pressure, basically riding cosmic winds like tiny invisible kites. And last but not least, the showstopper, directed panspermia, where advanced extraterrestrial civilizations intentionally seeded planets like ours with life. Think of it as aliens playing Johnny Appleseed across the universe. Now, before you start picturing little green men sprinkling microbes like cosmic fairy dust, know this: some of history's greatest scientific minds took panspermia very seriously. Swedish chemist Svante Arrhenius, a Nobel Prize winner, was one of the first to propose that life's building blocks could be carried through space by radiation pressure. Then there's Fred Hoyle, the astrophysicist who coined the term Big Bang, though he wasn't a fan of the idea. Hoyle and his collaborator Chandra Wickramasinghe suggested that interstellar dust and comets might be packed with organic compounds and microbes just waiting to spark life somewhere. And here's where it gets really wild. Francis Crick, the guy who co-discovered DNA's double helix, was also intrigued by panspermia. Crick thought DNA was so complex, like ridiculously intricate, that it probably didn't form spontaneously here on Earth. He argued that its existence might hint at deliberate extraterrestrial design. In other words, DNA might be the ultimate alien calling card. Now, let's bring it down to Earth. Or maybe not. There's even a theory that human biology has cosmic fingerprints. Take meibum, the oily stuff that keeps your eyes from drying out. Its molecular structure is suspiciously similar to organic compounds found in meteorites. So while we're out there searching for alien material, maybe some of it is already inside us. But wait, there's more. Nature is full of extreme survivors called extremophiles. Think of them as nature's overachievers. Take Deinococcus radiodurans, aka Conan the bacterium, and I apologize if I didn't enunciate that word correctly. This little champ can survive radiation, heat, cold, and even the vacuum of space. It's like the ultimate cosmic hitchhiker. Space experiments have shown that tardigrades, lichen, and certain bacteria can survive direct exposure to space's harshest conditions. If these tiny creatures can hack it out there, why not microbes on a comet? Speaking of comets, let's talk about the Murchison meteorite. When this space rock crash landed in Australia, scientists found it was packed with organic molecules, including amino acids, the building blocks of life. That's like finding a fully stocked pantry in the middle of nowhere. It suggests that meteorites could deliver life's essential ingredients to planets like Earth, jump-starting the process. So, is panspermia just another sci-fi idea? Not really. It's backed by solid science, experimental evidence, and some of the brightest minds in history. Sure, it's not a slam dunk, but it fills the gaps left by Earth-only theories. Life's resilience, the transport of organic molecules through space, and the rapid evolution of life on Earth all point to something astonishing. Maybe we're not native to this planet. Maybe we're cosmic hitchhikers, carried to Earth by the stars themselves. Let's dive into the mind-blowing discoveries that have taken panspermia from sci-fi nerd theory to something that makes you go, wait, could this actually be real? These aren't just random ideas doodled on a chalkboard. They're real-world findings that are tough to ignore. First up, let's talk about microbes. These tiny overachievers are like the universe's ultimate survivalists. Recently, scientists pulled off something straight out of a sci-fi movie. They revived 100 million-year-old microbes that had been chilling, or well, not chilling, in ocean sediment since dinosaurs were stomping around. Yep, you heard me right. 100 million years. That's not just a long nap, it's a full-on cryosleep marathon. And when they woke up, these little guys, they didn't just survive, they started replicating. But wait, it gets wilder. Researchers also revived tiny nematodes, aka microscopic worms, that had been frozen in Siberian permafrost for 46,000 years. At first, nothing happened. Scientists thought they were dead, and there was nothing more to it. But then, one of them decided to start applying gradual heat to them from just a hunch. And what did these little guys do when thawed? They started wiggling, eating, and generally acting like nothing happened. It's like they literally came back to life. Let that sink in. Tens of thousands of years on ice, and these worms are just like, no big deal, where's the buffet? To put this in perspective, it's like digging up a rusty old car in the desert, giving it a bit of gas, and not only does it start, it transforms into a fully loaded Tesla. That's the kind of resilience we're dealing with here. These microbes and worms survived crushing pressures, freezing temperatures, and zero food, only to spring back to life the second conditions improved. This discovery really flips the script on what we thought life could endure. If microbes can survive 100 million years buried on Earth, why not millions or billions of years cruising through space? Conditions we once thought were game over, vacuum of space, cosmic radiation, extreme cold, are starting to look more like minor inconveniences. This kind of resilience changes the panspermia game. Suddenly, the idea of life hitching a ride on comets or asteroids and surviving interstellar road trips doesn't just seem possible, it's starting to feel inevitable. Speaking of space travel, let's talk about comets. Remember the Rosetta mission? It was that ambitious project where a spacecraft landed on the comet 67P. What did it find? Organic molecules, including glycine, which is one of the amino acids essential for life. That's like opening a cosmic care package and finding all the ingredients for life neatly packed inside. Comets, it turns out, are like the universe's Amazon Prime, delivering life's starter kit to planets across the galaxy. Now, here's where things get really juicy. Directed panspermia. This theory takes panspermia to the next level and suggests that advanced extraterrestrial civilizations might have intentionally seeded planets, including Earth, with life. Imagine alien gardeners flinging microbial seeds across the cosmos, hoping something cool would sprout. It's bold, it's controversial, and it's not as far-fetched as it sounds. I mean, if we're already dreaming up ways to terraform Mars, why wouldn't a super advanced civilization have had that same or better tech? Whether life came here via meteorite, a comet, or an alien FedEx delivery, one thing is clear: life's story might stretch far beyond Earth. And if that doesn't make you rethink everything, buckle up, because we're just getting started. There's so much more to uncover. Let's zoom out for a second, like way out. While Earth gives us plenty of clues about panspermia, the real action might be happening far beyond our little blue marble. If life can hitch rides across space like a cosmic rideshare, shouldn't we be looking for its next pit stop? Here's the wild part: our galaxy is packed with places that could potentially host life, or maybe already do. Take Europa, one of Jupiter's moons. Beneath its icy surface is a massive sloshy ocean warmed up by Jupiter's gravitational pull. Yep, a whole hidden ocean just chilling under miles of ice. And where there's water, there might be life. Think microbes having the time of their tiny lives. Then there's Enceladus, the moon of Saturn. This little guy is basically shooting its resume into space, with icy geysers spewing water vapor and organic compounds, life's building blocks. It's practically screaming, hey, life might be here, come check it out. Now, let's talk about Titan, Saturn's largest moon. It's a whole different vibe. Sure, it's freezing, but it's got lakes of liquid methane and ethane, basically super chilled natural gas. What if life there doesn't even need water? And don't sleep on Venus either. Sure, the surface is hotter than your barbecue grill, but its upper atmosphere? Perfectly cozy, with temperatures and pressures similar to Earth. Some scientists think microbial life might just be floating around up there like microscopic skydivers. Oh, and Ceres, the dwarf planet on the asteroid belt, gets an honorable mention. It has briny water reservoirs on its surface, suggesting it might have supported life, at least for a bit. It's like the cosmic equivalent of a rest stop. Not glamorous, but hey, it works. Now zoom out even further. Scientists estimate there are around 6 billion Earth-like planets in the Milky Way alone. Yeah, 6 billion. That's a lot of potential for life to crop up. These are planets in their star's habitable zone, basically the Goldilocks area, where it's not too hot, not too cold, and liquid water could flow. If even a tiny fraction of those planets have the right conditions, panspermia spreading life across the galaxy stops sounding like sci-fi and starts feeling like a no-brainer. Think about it. Microbes are like the ultimate interstellar tourists. They survive the vacuum of space, radiation, freezing temperatures, you name it. They hitch rides on space rocks, cruise through the cosmos for millions of years, and then land on some unsuspecting planet ready to throw a biological housewarming party. These aren't just wild ideas or wishful thinking. The evidence from Earth's toughest creatures to the organic molecules found on comets suggests that life isn't just tough, it's designed to spread. Every time we study a comet, a moon, or even a meteorite, we're getting closer to answering the big question: are we alone? And the answer, well, it might not be on Earth. It could be hiding somewhere out in the endless, starry abyss. As we take a step back from all the theories, mysteries, and what ifs, one thing is crystal clear. Life on Earth is nothing short of mind-blowing. Whether it bubbled up from some primordial soup, hitched a ride on a comet, or was dropped off by aliens playing cosmic Johnny Appleseed, the implications are huge. If panspermia or anything remotely like it is true, then we're not just Earthlings. We're the universe's kids, tied to the stars by a thread that stretches across time and space. So who or what kicked this whole thing off? Was it some random cosmic dice roll? Or divine zap of inspiration? Or some ultra-advanced beings pulling the ultimate science experiment? These aren't just fancy questions for scientists in lab coats. They're the kinds of questions that make you look up at the night sky and wonder where we fit in this crazy cosmic puzzle. And here's the humbling part. What if we're not just from Earth, but from everywhere? What if the atoms that make us were forged in ancient stars, then flung across galaxies like nature's confetti. That means every one of us is carrying a little piece of the cosmos, literally stardust in human form. It's a wild thought, right? It's like the universe made us from its greatest hits playlist. The mysteries of the universe aren't there to drive us nuts, although, let's be honest, they do. They're there to spark curiosity, to get us asking the big, unanswerable questions, and to keep us scanning the skies for truths that always seem just out of reach. It's like the universe is playing the ultimate game of hide and seek with its secrets. And honestly, that's part of the fun.
You have done well to ask these questions, to look beyond what is given and seek what is hidden. My kind sowed the seeds of life across worlds, not out of conquest, but out of hope. We wanted the universe to teem with life, to thrive, to grow, to evolve beyond even our comprehension. But we are not omnipotent. The journey to find your origins is now yours. Keep looking, keep asking. The answers are not beyond you. They are within you. Every star you chart, every question you dare to ask brings you closer to the truth and to us. We are watching, waiting, and hoping that one day you will find your way back, not to us, but to the infinite home we all share among the stars.
Thanks for sticking around and taking this wild ride with me today. I'm Ralph, and you've just wrapped up another fascinating adventure on Divergent Files. If you laughed, learned, or just didn't hate it, do me a favor. Hit like and subscribe and tap all the buttons that make the algorithm gods happy. Here's the thing. You're not just the audience. You're the secret sauce that makes this channel what it is. Your curiosity and your wild theories fuel everything we do. So do you have a topic you'd like for us to tackle next? Drop them below in the comments because I actually read them all, and who knows, your idea might just inspire the next video. Also, please consider going the extra mile and joining the Divergent Files crew over on Patreon. For as little as $3 a month, you'll get some pretty cool exclusive perks, and let's be honest, you'll also be helping us keep this channel going. Finally, here's what I want you to remember. This channel isn't just about making content. It's about digging into stories they'd rather keep buried and asking the questions no one else wants to touch. You are the core of this journey. Your curiosity keeps this engine running, and I can't wait to explore the next topic with you. Until next time, stay curious, stay kind, and remember you are truly appreciated.